Yes, very good morning to everyone. Okay, you people's attended the offline classes in the college premises. Okay, so different faculties we handle for you classes, right? So we may be having some difference in the portion coverage. Okay, anyhow, so I will be going to revise the last topic what we have discussed almost in all the classes. Then we will continue with the new one. Okay, fine. So today we are going to see the branch instruction from the instruction set of 8051 microcontroller branch instruction. Just we are going to refresh. Okay, then we are going to see about the ports of 8051 microcontroller, how it is working as input port, output port, and their alternate function. Everything we are going to discuss today. Fine. Okay. So in branching instruction, we have told 3 types of addressing. Yes, can you people type it in the chat? What are the 3 types of addressing modes we have in the branch instruction? Kindly type it in the chat. Yes, very good, Dixon. Relative, absolute, long, very good. Okay, so long addressing range, absolute addressing range, then relative addressing range. Fine. So in the case of long addressing range, what about the range of branching? That means in the range kulla நம்ம வந்து jump பண்ணலாம் இல்ல ஒரு sub programmer call பண்ணலாம். Yes, if your program is anywhere in the 64 KB of the program memory, okay, anywhere you can jump or call the subroutine from the particular address. Yes, that we call it as long addressing. What about the size of the address we are going to mention for long addressing? Long addressing அப்படின்னு சொல்றப்ப what about the size of the address we have to give in the instruction? (16-bit address or 8-bit address? Yes, very good. 16-bit address. Okay. In the case of absolute addressing, what we have done first, how the 64 KB is managed. In the case of absolute addressing, quicker type பண்ணுங்கப்பா. Yes, the entire memory is divided into 32 pages. Yes, so page concept நம்ம யூஸ் பண்ணுவோம். What about the size of each page? Yes, 2 KB. Yes, for addressing a memory location in the page, how many bit address is enough? Page, it is going to be selected by the program counter first 5 bits. Yes, the MSB 5 bits of the program counter will select the page. Yes, what about the remaining bit? Yes, 11-bit address we are going to use. So in that 11-bit address, 8-bit we are going to mention. That means lower byte of the address we are going to mention as a second byte of the instruction. The first byte of the instruction, that means the output, it is going to mention the another 3 bits. So totally we will be having 16 bits. Yes, the MSB 5 bits from the program counter itself, the next 3 bits from the output, the remaining 8 bit only we are going to mention in the instruction. Yes, is it clear to everyone? Okay, what about in the case of relative addressing range? What about in the case of relative addressing range? We can jump forward by 127 location or reverse by 128 location. Yes, so here we are going to mention only the relative offset value, which is a 8-bit signed number. Okay, based upon its value, we will be going to jump. The program execution is going to be transferred forward or reverse. What about the range? Minus 128 to plus 127. Yes, fine. So that and all we have discussed in the theory session. Yes, okay. So these are the instruction comes under the long addressing branch instruction. That means anywhere you can jump. Okay, you can call any program from any memory location out of the 64 KB location. Yes. Similarly, you can jump anywhere using the JMP instruction, and return and RETA or return instruction, you can return to the main program. Wherever you will be called from the program, you can go to that place. So these instructions are categorized as long addressing branch instruction. Okay, fine. Absolute addressing, we are having only 2 instructions, A jump and A call. Okay, A jump and A call. The first letter of the branch instruction, L jump, L call indicates long addressing. Similarly, A jump, A call indicates absolute addressing. Okay, so all other instruction that we are listing under relative addressing branch instruction. Yes, so the previous two things are unconditional. Long addressing lo ulla ella instruction enadhu unconditional. Similarly, absolute addressing lo ulladum unconditional. Whereas in the case of relative addressing, except sjump, all other instructions are conditional branch instruction. Yes, that's why it is highlighted in different color. Yes, shall we see the instruction? Shall we see the instruction? Yes. Okay. So first we will, then one more instruction we are having. It is not categorized under any addressing range. Okay, it is no operation instruction. Fine. Okay. So in the branch instruction we are having long addressing instruction. LJMP, it must be provided with a 16-bit address. Then LCall, it must be provided with a 16-bit address. Then JMP, here the branch address is calculated by the sum of accumulator and the DPTR register. Okay, so based upon the value of accumulator in DPTR, your program execution is going to be transferred to the particular memory location. Okay, yes, then RET, then RETA. These are the instruction we are having. In the case of absolute addressing, even though we are mentioning address 11, we are going to provide only 8 bit. The remaining 3 bit is from the A jump output and A call output. Yes, fine. So relative addressing, S jump is a unconditional branch instruction. JC means what? This particular instruction, JC checks which flag? Like your 8085 only. Yes, it will check the carry flag. If carry flag is 1, then it will go. That means jump if carry. Yes, JNC means jump if no carry. JZ means jump if accumulator is 0. Jump if accumulator is not equal to 0. Fine. Then JB means jump if a bit is set. So what we have to mention here, in the case of JC, JNC, JZ, JNZ, we are having a condition tested by the carry or accumulator condition. Fine. In the case of JB, we have to mention the bit. If this particular bit is set, then it will go to the address calculated by the offset value. Yes, I hope it is clear. If the bit is set, then it will branch to the address given by the offset value. Yes, similarly, jump if the bit is not set. JNB, then JBC means jump if the bit is set and also clear the bit. Yes, if the bit is set, then it will jump to the location. Also, it will clear that particular bit. That's it. Fine. DJNZ. We have discussed about this instruction in the lab session itself. DJNZ means what? DJNZ stands for what? Kindly type it in the chat. DJNZ. Decrement a register content. If it is non-zero, then it has to be jump. Correct? So we have to mention the name of the register. Okay. I think here a mistake is there. Sorry. I'm sorry. Wait a minute. So here data must not come. Yes. DJNZ, the register name, comma, the offset value we have to give. Similarly, DJNZ, the memory location content can be decremented, and if it is non-zero, we can jump based upon the offset value. I hope it is clear now. Is the screen is visible to everyone? Is the entire screen is visible to everyone? Yes? Yes. Okay, fine. Okay, thank you. Fine. So DJNSF means we are specifying a register in the instruction. It will get decrement by 1. If it is non-zero, then it will branch to the location based upon the offset value. Yes. Then CJNE means what? CJNE. CJNE. D stands for decrement. Here C stands for yes. Can you people type it in the chat? Yes. Compare, jump if not equal. Fine. So obviously we need two parameters to compare. So one is from accumulator, the other thing can be immediate data, or one is from accumulator, the other thing can be from the RAM memory content. Yes. Similarly, a register content can be compared with the immediate data, or the RAM memory pointed indirectly by a register R0 or R1 with the immediate data. Yes. Yes. Is it clear? So here I missed the relative offset value. Wait a minute. Okay, fine. Yes, CJNE means we have to give two parameters. One can be a register content, other can be immediate data. Yes, one from accumulator, the other can be immediate data, or it can be from a RAM memory location. Similarly, you can do with register with immediate data, RM, that means R0 to R7. Any register you can replace here. In the case of the last instruction, CJNE at RI, so here the RAM memory is indirectly pointed by R0 or R1. It is going to be compared with the immediate data. If it is not equal, then it is going to jump to the specified location by the offset value. Yes, I hope it is clear to everyone. So the final instruction is NOP, no operation instruction. So that's all about the branch instruction. Yes, is it clear to everyone? Is it clear to everyone? Okay, fine, fine. Okay, so these are the instruction under the branch group of instruction. Okay, so kindly take a screenshot of this slide. LJMP means just the 16-bit address. It is going to be stored into the program counter. That's all. Whereas in the case of LCAL, like your 85, first what happened? Program counter has to point the next instruction. As it is a 3-byte instruction, first the program counter get incremented by 3, then the stack pointer get incremented by 1, so that it point a empty location. There the lower byte of the program counter, which is the next instruction address, that means the return address. Yes, it gets stored into the memory pointed by stack pointer. Again, to store the higher byte into the stack, again stack pointer get incremented by 1. Now the higher byte will get stored into the memory pointed by stack pointer. Fine. So now what happened? The next instruction address is stored into the stack. The content of PC is pushed into the stack. Correct? Then after that, the address we have given in the instruction, it is getting into the program counter. That's all. I hope it is clear to everyone. As it is a call instruction, the next instruction address available in the program counter must pushed into the stack. Then it branches to the given address. That's the thing happening in the steps. Yes. Shall I move to next slide? So here the 16-bit address directly we will mention. For example, the instruction can be like this: LJMP 8000H. Yes, or LCAL 9000H. So here the address is 16-bit. This is an example for the instruction. I hope it is clear to everyone. Yes? Yes or no? Yes, fine. Next. Similarly, in the case of absolute addressing, AJump, ACAL, we are having two instructions. Okay. First, the program counter get incremented by 2 because AJump, it is going to have an opcode. Fine. Then here we will be going to give only the 8-bit of the address. Out of the 11-bit, we are going to mention only 8-bit. That means the lower byte of the address where it has to jump, or the program where it has to call. Yes, so first the program counter gets incremented by 2. Fine. Now it will check. It will check whether the branch we are going to make is within the page or it is outside the page. If the range is within the page, your program will get executed successfully. That means proper assembler. If your range is outside the page, the assembler will show you an error. Yes. So here the program counter gets incremented by 2 such that the upper 5 bits it is going to be fixed. The other 11 bits. Fine. The other 11 bits, how it is coming? 3 bits from the opcode and 8 bit we are going to mention. That means lower byte of the address only we are going to mention. Okay. The other things is with the opcode itself. Okay. So here the example is AJMP. Say for example, if I want to branch to 8,300, okay, or 8,350. So I have to give only the lower byte in the instruction. Yes, what about the lower byte? If I am saying the address as 8350H. 8350H, the lower byte another. Can you people type it in the chat? 8350H. Yes, 50H is the lower byte. Fine. So the instruction must be like this. So lower byte of the address we will mention in the instruction. Fine. The upper 5 bits is from the program counter itself. The AJump and the ACall will be going to have 8 outputs for the same instruction in the output chain. Based upon the page and the range, you have to choose the corresponding AJump and the ACall. Fine. So that is going to give the 3 bit of your 16-bit address. So by total, you will be going to have 16-bit address in this way. That's all. Okay. So here also, program counter get incremented by 2. Stack pointer pointing to the next memory location. Lower byte gets stored. Again, it get increment to point the next memory. So higher byte gets stored. Then the 11-bit address is getting into the program counter because the 5-bit it is going to be remain same. So that is not mentioned here. Program counter size ethanapa. What about the size of the program counter register? Kindly type it in the chat. Program counter ethana bit register? Yes, 16-bit register. Correct? So 11-bit தான் நம்ம கொடுக்கிறோம். 5-bit it is as it is. எந்த பேஜ்ல இருக்கிறோ அந்த பேஜ்க்குள்ள தான் ஜம்ப் பண்ண முடியும். So within the page, the first 5-bit of the address is going to be same. You can check it. Okay. So that's all about the AJump and the ACall instruction. Fine. Then SJump. Here, what is going to happen is program counter gets incremented by 2. Okay. After it gets incremented by 2, that means the next instruction it is going to be the reference. From there, the relative value is going to be added. Yes. I hope it is clear to everyone. Program counter la enna value irukko adu kuda enak enna agum, the offset value it is going to add. Positive value na add agum, negative value na subtract agum. That's all. As it is a sign number, if the relative offset value is positive, it will get added. If the relative value is negative, it will get subtracted. That's all. Say for example, I have to move 5 steps backward. So what about the offset value? Can you people type it in the chat? I have to move reverse by 5 steps. 5 bytes I have to move reverse. So what about the offset value you have to mention? Is good example பார்க்கலாமா? Yes. -5 signed 2's complement la எப்படி represent பண்ணுவோம்? So first +5 க்கு நான் டைப் பண்றேன் இந்த chat. Yes. This is for +5. This is for +5. So what about the MSB here? It is 0. Correct? Kindly take 2's complement for this. What you will get? Can you type it in the chat? Yes. See, 5 bytes na reverse la jump panna poren appadina enakku enna value kedikum? Yes, very good. Can you people type the answer in hexadecimal value? Yes. F, B, H. Very good. Very good. So what about the instruction we have to use? If I want to jump 5 steps backward, SJMP FBH. That's all. So this is the instruction actually we have to use. But in general, in using in the software, what we are preferring? See, நம்ம program lab la பண்ணுவோம் இல்லைங்களா, அதுல branch instruction SJMP பண்ணப்பலாம் நம்ம என்ன பண்ணுவோம்? Whether we give the offset value or what we have did. SJMP க்கு பக்கத்துல என்ன போட்டோம் ஞாபகம் இருக்கா lab programல எல்லாம்? Yes, very good Shivakumar. We used to label, correct? When you are using a software, you will be going to have an assembler. Yes, so that will do this part of things. You can see the opcode assemble ஆனதுக்கு அப்புறம் செக் பண்ணி பாத்தீங்கன்னா தெரியும் SJMP ஓட opcode வந்துரும், followed by you will be going to have a 8-bit value based upon the label what you have given in the program. Okay, so the எத்தனை byte forward ல போகுது reverse ல போகுதுன்றத பொறுத்து it will vary. Okay, if I want to jump 7 location forward, what about the instruction we have to use? If I want to jump 7 location forward, what about the instruction we have to use? Yes, can you people type it in the chat? The reverse will not type on the forward. Very good answer, Surya. SJMP 07. Very good. That's the correct answer. SJMP 07. So 7 location, you can jump forward. That's all. Fine. So the relative addressing mode is only for jump. It is not available for call instruction. Kindly note down. Fine. So now we have discussed this unconditional jump instruction. Okay. So conditional அப்படினா ஒண்ணும் கிடையாதுப்பா. JC னா என்ன ஆகுது பாருங்க. First program counter which is getting incremented by 2. Okay. Then if carry flag equal to 1, then the offset value will get added. Else nothing going to happen. It will execute the next instruction. That's all. Condition true ஆ இருந்தா மட்டும் தான் என்ன ஆகும்? Relative value will get added with your program counter. Else program counter value remains same. That means incremented by 2 means next instruction it is going to be executed. Similarly, JNC means if carry equal to 0, then offset value will get added. That's all. Then, if you want, you can take a snapshot. I'll move to the next slide. Shall I proceed? Yes. If you people want to take screenshot, you can take it. Shall I move to next slide? Yes, fine. Now, JZ. JZ means what? If accumulator content equal to 0, offset value is getting added with program counter. Fine. JNZ means if accumulator content is not equal to 0, then offset value get added with program counter. So that it branches to the corresponding location if the condition is true. That's it. Fine. Then JB means if the content of the bit is set, then offset value get added. If the content of the bit is 0, that means bit not set. J and B, jump, no bit. Offset value get added. Fine. Here in the case of JBC, what is going to happen? Here it is 3 byte instruction, so it is first getting incremented by 3. If bit equal to 1, then what happened? Bit on the clear item, then offset value get added. I hope it is clear. JB ku JBC ku any difference pa? JB la the bit location oda logic change aga. JBC la enna agum? If the bit is set, it will jump to the location as well as it will clear the bit. That's all. I hope it is clear to everyone. I hope it is clear to everyone. JB ku JBC ku any difference? In the case of JB, the bit is set, it will jump to the location. That's all. In the case of JBC, it will jump to the location, also clear that corresponding bit. That's all. Fine? Okay, next. BJ NZ. Here what happened? Program counters first get incremented by 2. Then the register content get incremented by 1. If it is not equal to 0, then it jumps to the specified address. That means offset value get added. See, condition true or irundha mattumda offset value add out. Else it won't get added. That's all. That's why we are calling this instructions as conditional branch instruction. Similarly, the content of the RAM get decremented by 1. Okay, if that value not equal to 0, then offset value get added with program counter. That's all. DJNS. Similarly, compare போறப்ப என்ன ஆகும் அப்படின்னு பாத்தீங்கன்னா program counter gets incremented by 3, then content of accumulator compared with immediate data. Yes, if not equal, then offset value get added, so it branches to the particular location. And if accumulator content is less than data, then carry flag is set, else carry is reset. See, you have to note down, இது வரைக்கும் நம்ம பார்த்த இன்ஸ்ட்ரக்ஷன்ல இது கொஞ்சம் புதுசு, கரெக்டா? ஸோ இதுல ஃபிளாக்ஸும் அஃபெக்ட் ஆகுது. whereas decrement போறப்ப நமக்கு flags எதுவும் affect ஆகல. So here carry flag get affected based upon the comparison result. I hope it is clear to everyone. I hope it is clear to everyone. See, accumulator data is compared with the immediate data. Fine. If it is not equal, then it jumps to the specified address based upon the offset value. Fine. At the same time, the data is lesser than A. The data is lesser than accumulator content. Carry flag will get set. Else carry is going to be reset. That means carry flag definitely it is going to affect when you are executing CJNE instruction. Fine. So here the comparison is between accumulator and immediate data. In the next instruction, it is between accumulator and the RAM memory content. Fine. In the next instruction, it is going to be with a register content with immediate data. Fine. In the next instruction, it is going to be with the register. It is going to point a RAM memory location indirectly, that is compared with the immediate data. That's all. See, the parameters, what is getting compared is going to change, but the operation of the instruction remains same. CJNE means something is going to be compared with other thing. If it is not equal, the offset value get added with program counter, and the carry flag will get affected based upon whether the result is, the source is lesser than the destination. That's the thing. Okay, so that's all about the CJNE instruction. Now, RET we all know. Fine. So return instruction அப்படின்னு சொன்னா ஸ்டாக்ல நம்ம புஷ் பண்ணி இந்த அட்ரஸ் தான் திரும்ப ப்ரோக்ராம் கவுண்டர்ல போட போறோம். ஃபர்ஸ்ட் ஸ்டாக் பாயிண்டர் பாயிண்ட் பண்ற மெமரி லொகேஷன்ல இருந்து ஹையர் பைட் ப்ரோக்ராம் கவுண்டருக்கு போகும். Then stack pointer decrement by 1 points the lower byte of the return address, that will get stored into the program counter. Again, stack pointer get decremented by 1 to point a filled location. That's all. That's all about the return instruction. The same thing happened for RETA also, but where we have to use RETA instruction? Return from ISR, return from interrupt service routine. See, in a normal subprogram, the main program return aguna, you have to use RET instruction. If you want to return from the service routine of an interrupt program, then you have to use RET. I hope it is clear to everyone. Your main program run it. If it is currently diverting to interrupt service routine, then you have to use RETI at the end of the subprogram. That's all. And finally, JMP at A plus DPTR. Here, accumulator plus DPTR get added. So to that value, it is going to copy to program counter. That's all. JMP at A plus DPTR. The sum of accumulator and DPTR is going to form a new address. To that address, the program is going to be branching. That's all. Then NOP, we all know, no operation instruction, nothing going to happen, as it is 1 byte instruction. After executing this instruction, program counter get incremented by 1. That's all. Okay, so that's all about the branch instruction, all the branch instruction. I hope it is clear to all the classes. Yes. Yes. Okay, the next topic what we are going to discuss is port. Fine, port of 8051. Before that, we have some questions. What is the range of bytes that can be jumped using SJMP relative addressing? SJMP instruction use பண்ணோம்னா, what about the range of jump? Yes, minus 128 to plus 127. That means plus 127 bytes forward or minus 128 byte reverse jump. What is the size of a page in absolute addressing? Yes, 2 KB, very good. Which instruction of 8051 can be used to jump any location within 64 KB of home address space? Jump to any memory location. Yes, very good. LJMP 16-bit address, very good. Okay. Which instruction of 8051 is used to return the program execution from subroutine? Subprogram leni main program ponna enna instruction? Very good. RET. If it is from ISR program, which instruction we have to use? Return the program execution from interrupt service routine. Yes, RET, that's all. Okay. So now we can discuss about the ports of Intel 8051. So here we are going to discuss how the circuit of your ports. Fine. உங்களுக்கு போர்ட் அப்படின்றது ஒரு ஹார்ட்வேர் சர்க்யூட் கரெக்ட்டுங்களா? ஸோ அந்த ஹார்ட்வேர் சர்க்யூட் ஒவ்வொரு போர்ட்லையும் எப்படி இருக்கு, their functionality we are going to discuss now. Fine. Okay. So 8051 have 4 bidirectional IO ports. What are the 4 ports? Can you people type it in the chat? 4 port இருக்குன்னு படிச்சோம் கரெக்ட்டா? Yes. Port 0, port 1, port 2, port 3. Fine. What about the size of each port? How many pins we will be going to have in each port? Yes, very good. So it is a 8-bit port. Fine. Fine. Okay. So what about the registers? What about the registers? For each port we are having, to program each port, what are the registers we are having? ஒரு போர்ட்டையும் ப்ரோக்ராம் பண்றதுக்கு SFR இருக்குன்னு படிச்சோம் கரெக்ட்டா? No, R0 to R7 are register bank register. I am asking about port registers. We have discussed in the lab session. I hope so. Port 0 ல ஒரு கண்டென்ட் எழுதணும்னா அந்த SFR என்ன யூஸ் பண்ணும்? No Antony Surya P0 to P7 வராது. We are having 4 ports, correct? For each port we are very good, lovely. Port 0, port 1, port 2, port 3. 4 registers we are having, each register for its corresponding port. That's all. So the basic function of IO port is to interface external devices with microcontroller. I hope so. Apart from this, port 0, port 2 and port 3 have some alternate function. Whenever a port pin is used as an input pin, that means for read operation, its corresponding port latch bit must be written with logic 1. Okay, so this is நம்ம எல்லாருக்குமே தெரியும் நினைக்கிறேன். I hope we have discussed these things in the lab session. Now we will discuss more about the port registers. Before that, we will see the alternate function of ports. What about the alternate function of port 0 and port 2? Can you people type it in the chat? Apart from connecting input-output device with port 0 and port 2, for what purpose it can also be used for? Yes, very good. Address and data bus. Yes, port 0 and port 2 combinedly it is used as address and data bus for accessing the external program or data memory. Fine. Okay. What about the purpose of port 0? What about the alternate function of port 0? Port 2 acts as a higher order address bus during external memory access. Port 0 acts as a time multiplexed lower order address and data bus during external memory access. Fine. I hope it is clear. See, ரெண்டு போர்ட்டுமே address data bus யூஸ் பண்றோம். இருந்தாலும் port 2 carries only the higher order bytes or upper 8-bit of the 16-bit address. Port 0 is going to have a multiplexed lower order address and data. Fine. Then alternate function of port 3. So in the case of port 0 or port 2, its alternate function is a common functionality. Entire port is used as an address data bus. What about in the case of port 3? Each and every pin of port 3, it is having individual alternate function. Yes, each pin of port 3 has individual alternate function as going to be mentioned below. Okay, can you take a screenshot? Port 3 oda 0th pin serial data reception kaga use agapodhu. Port 3 oda bit 1, it is used for TXB, transmission of serial data. P3.2 and 3.3 are going to be act as a external interrupt. See, in your system or application, if you are having external interrupts, so you have to use P3.2 and P3.3. There is no dedicated pin for interrupts. Port 3 oda alternate function na enadhu interrupt pins are use agudhu. Fine. Then P3.4 and 3.5, when you are configuring the timer bar counter as counter, adhu kudukkudiya count input T0 T1, it is through P3.5 and 3.4. Fine. Then 3.6 and 3.7 for read write signal work. Fine. When accessing the external memory, so these two pins are used for read and write operation. External data memory access pandappa, these two signals are nothing but the control signals, okay, which enables the read or write operation from the external RAM. That's all. So these are the alternate function of port 3 pins. Yes, is it clear up to this? Yes. Okay. After this portion of today's session, we'll be going to interact more, because port order operation உங்களுக்கு animate பண்ணி காமிக்க போறேன். So I will be going to ask you question, you peoples are going to be answer. Fine. Okay. So SFRs of IO port, as we discussed earlier, port 0 to we are having P0 register. Fine. So it is a 8-bit register. Each bit corresponds to the individual port pins. Yes. So their names are P0.0 bit address. See, you can write an 8-bit data together into the port register. That means byte operation. So at that point of time, we have to use the name P0 or address 80H. When we are doing a bit operation on the port pin, at that time we have to use the name P0.0 to P0.7. Fine. So each bit, it is having a unique name or a unique address. So inge kuduthirukkiradhu bit address for each bit of the port 0 register. Similarly, for port 1, it will be like this. Yes. For port 2 and 3, it is going to change like this. That's all. Fine. That's why we are saying 32 individually addressable IO lines we are having. It can be grouped as 4 8-bit port, or each pin can be used to connect a 1-bit device, which can be a switch or an LED, whatever it may be. Fine. Okay. Now we are going to discuss about the working of port 1. Fine. Why we are going for port 1 initially? Can you people type it in the chat? Port 0, port 1, port 2, port 3. First, we will port 1. Can you people have any idea why we are discussing port 1 initially? Out of the 4 port, why we are choosing port 1? It is an odd port. How? Yes, very good, Andrew Surya. As it has no alternate function, easily you people can understand. That's why we are starting with port 1. Okay. So, சில பேருக்கு கேள்வி வரலாம், சார் ஏன் சார் எடுத்த உடனே port 1 போறோம், port 0 போகாம? The reason behind this is the operation of port 1 can be easily understood by anyone. Fine. Okay. So operation of port 1. Fine. What are the different operation you can do with the port? Can you people type it in the chat? For a port pin la enna operation la panna mudiyum? If I am connecting an input device, what operation we can perform? Read operation. Very good. If I am connecting an output device to the port pin, yes, write operation. So we can write or we can read. There are two major operations. Apart from that, we have one more operation that we call it as read, modify, write. இதுக்கு மீனிங் யாருக்காவது புரிஞ்சிருந்தா நீங்க சாட்ல டைப் பண்ணலாம். ரீட், மாடிஃபை, ரைட். இதுக்கு மீனிங் ஏதாவது புரிஞ்சுதா? ஒன்னு ரீட் பண்ணலாம் இல்ல ரைட் பண்ணலாம். இது என்ன சார்? ரீட், மாடிஃபை, ரைட். ஓகே, ஒரே ஒரு இன்ஸ்ட்ரக்ஷன் நான் எழுதுறேன், அதுக்கான மீனிங் என்ன நீங்க கன்வே பண்ணுங்க. எஸ், வெரி குட் ஆண்டனி சூர்யா. It will read the content and modify it, then place back to the same place itself. Okay, for example, CPL P2.0. What will happen? CPL P2.0. Can you say it is a write operation or read operation? CPL P2.0. What is the meaning? What is the meaning first of all for this? Yes, complement the logic available in the port pin P2.0. Correct? Not complement carry Dixon. We are complementing a port pin. Fine. How you can complement? First of all, see, the port pin la enna logic irukku theriyama eppadi na vandu complement panna mudiyum. Say for example, if I am asking you to do an inverse operation, what you have to do? இப்ப என்ன லாஜிக் இருக்குன்னு நமக்கு தெரியும், அதை காம்ப்ளிமெண்ட் பண்ணணும், then we have to write. Correct? So this kind of instruction we can call it as read, modify, write. Say for example, இது கூட சொல்லலாம். என்ன சொல்லலாம்? DEC P2. What is the meaning for this? What is the meaning for this? Can you people type it in the chat? Yes or no? Yes, read the logic. Okay, read the 8-bit value. Read the 8-bit value from the port. Then it has to be decrement by 1. That is modified. Then write back to the same register itself. This operation we call it as read, modify. So by total we are having 3 basic operations. What are they? Now can you people list out? Read operation. Yes. Then write operation, then read, modify, write operation. I hope you people can understand these things. Yes, shall we proceed? Yes, fine. Okay, now it's very important thing. We are going to recollect the basic of digital and electronic devices. Okay, or electronic circuit. See, இது பயந்துக்க வேணாம், ரொம்ப சிம்பிளான ஒரு அனிமேஷன் தான் இங்க நம்ம பண்ண போறோம். Fine. So that easily you people is going to understand the operation of code. Fine. First we will go with the write operation. Fine. Can you people type it in the chat? What are the two things you can write in a single port pin? ஒரு port pinல நம்ம ரைட் பண்ண போறோம்னு சொன்னா ரெண்டு விஷயம் தான் ரைட் பண்ணலாம். ஒன்னு என்ன இருக்குல்ல, what about the other one? Yes, very good. Logic 0 or logic 1. Can you people type it in the chat? Logic 0 எழுதணும் அப்படின்னா என்ன இன்ஸ்ட்ரக்ஷன் யூஸ் பண்ணணும்? If I make a pin to logic 0, which instruction I have to use? இதெல்லாம் நம்ம வந்து ஆல்ரெடி சொல்லி கொடுத்தாச்சு காலேஜ் வந்த பீரியட்ல. Logic 0 means what? Set or reset. Yes, very good, Shivakumar. CLR, very good. CLR space the port pin name. That's all. So clear. Fine. Logic 1 எழுதணும்னா, if I want to write logic 1 on the same port pin, what I have to do? Kindly interact. See, in the particular topic, interact பண்ணாம நம்மளால கத்துக்க முடியாது. Very good, Karthikeyan. Karthikeyan type yes. ETB. Kindly correct it, Kavyasri. It is not S bit. Set bit. SETB. Okay. Lovely type. SETB. Port pin. Say for example P2.0. Yes, this is an example. In the instruction execute panna enna agum? P2.0 pin will go to logic 1. Fine. Okay. Now we will go with the port 1 writing logic 0. Port 1 la நம்ம என்ன பண்ண போறோம்? Logic 0 write பண்ணோம். Please understand one thing. What about the size of each port? What about the size of each port? It is 8-bit. Fine. If one pin of a port is functioning in a way, the other 7 pins is going to be functioning in the same way. Is it correct or not? ஒரு போர்ட் எடுத்துக்கிறோம் அப்படின்னா ஒரு பின்னோட ஃபங்க்ஷனாலிட்டி எப்படி இருக்கோ அதே மாதிரி தான் என்ன ஆக போகுது, the remaining pins இருக்கும். கரெக்டா? Yes or no? Yes or no? See, port 0 அப்படின்னு எடுத்துக்கிட்டோம்னா port 0ல 8 லைன் இருக்கு. கரெக்டா? 8 pins. The functionality of individual pin தெரிஞ்சா போறோம், remaining 7 pins அதே மாதிரி தான் ஃபங்க்ஷன் ஆகும். Fine. So here we are considering only a single bit. ஒரே ஒரு போர்ட் பின்னை தான் நான் எடுத்துக்க போறேன், ஒரே ஒரு பிட்டை தான் நான் எடுத்துக்கிறேன். Fine. Okay. On seeing this, what are the components you can see from the circuit diagram? இது என்னன்னு சொல்ல முடியுமா? இந்த ஸ்கொயர் பாக்ஸ் இருக்கு இல்லையா, இது என்னன்னு சொல்ல முடியுமா? Yes. Yes. Can you people say? Digital நம்ம படிச்சிருக்கோம் அப்படின்னா அது கண்டிப்பா ஆன்சர் பண்ண முடியும். Okay. Flip flop. Okay, very good. Flip flop. என்ன type of flip flop? Very good. Danya Shivakumar, very good. It is D flip flop. D flip flop ஓட working நம்ம எல்லாருக்குமே தெரியும். கரெக்ட்டா? Whatever the data available in D, when clock is getting enabled, at that time the value available at pin D, it is going to store into the flip flop. Correct? Yes or no? Is it clear? Yes or no? See, D flip flop சொல்லியிருப்போம். அதோட ஆப்ரேஷன் என்ன? Whatever the data we are keeping on input, when clock is getting enabled, that value gets stored. Yes? Whether the logic is going to change after the clock is going to 0, and the flip flop la store on a value திரும்ப எப்ப சேஞ்ச் ஆகும்? Till we give a new input and clock get enabled. Correct? Okay. So that's all about this portion. Fine. So what about the size of port 0 register? Sorry, port 1 register. How many bit? Port 1 register எத்தனை bit இருக்கும்? 8 bit. Correct? So இங்க நான் என்ன பண்ணிருக்கேன் அப்படின்னா ஜெனரிக்கா சொல்லிருக்கோம். P1.x. What about the value of x may be? What about the value of x? P1.x been mentioned by what it mean? Yes, 0 to 7. All 7 pins of port 1, it is going to have this construction. So இங்க நான் மென்ஷன் பண்ணிருக்கிறது ஒரே ஒரு போர்ட் பின்னோட functional diagram, I mean circuit diagram. Similarly, you will be going to have same circuits 7 times. That means 8 pins we are having in a single port. All pins are like this. Fine. Okay. So the port register 8 bits சொன்னீங்களா, அதுல ஏதோ ஒரு bit தான் இந்த bit. Port register bit தான் என்னது latch அப்படினு சொல்றோம். Here we are mentioning only one bit of the port 1. That's all. So அது இதுதான். Port register 8 bitல இதுதான் ஒரு bit. சிம்பிளா சொல்லணும். Fine. Then what about the other components you can see? What about the other components you can see in this diagram? What about this portion? இது என்னன்னு சொல்ல முடியுமா? I'm pointing in the slide. Yes, very good. We have a pull-up circuit. Fine. So the pull-up circuit பத்தி நம்ம டீடைலா பார்க்க போறது இல்ல. But pull-up circuit அப்படின்னா மீனிங் என்ன? It is going to keep the pin high if no input is connected. That's all. Fine. What about this pin? This thing? What about this component? இது என்ன காம்போனன்ட் பா? படிச்சிருக்கோமே நம்ம எலக்ட்ரானிக் டிவைசஸ்ல படிச்சோம். Yes, very good. So it is a field effect transistor. It is a transistor. Basically, it is a transistor. Very good. Okay. Then we have two symbols here. This we call it as buffer with enable signal. That means buffer with enable. Okay. So the buffer na enable பண்ணாதான் எனக்கு என்ன ஆகும்? Input side ல உள்ளது output side. Yes. So how many latch we are having here, or how many flip flop we are having here? One flip flop and two buffers. Fine. With a transistor and a pull-up circuit. correct? So physically எனக்கு எது வெளியில இருக்குன்னு பாத்தீங்கன்னா இந்த pin P1.x, this pin. Fine. I have told all of you peoples two wordings. So right operation எப்பவுமே எங்க நடக்கும்? Right operation நீங்க எழுதி வச்சிருப்பீங்க, லேப் வந்தப்ப நான் சொல்லியிருக்கேன் அந்த வேர்டிங். Right operation is always on port register அப்படின்னு சொல்லியிருக்கோம். What about read operation? What about read operation? See, right operation கண்டிப்பா எப்பவுமே எங்க நடக்கும்பா? Port register நடக்கும். கரெக்டா? Read operation எங்க நடக்கும்? Port pin. It is not going to read the port register. Please underline this wording. Write to latch, read from pin. இது மட்டும் நோட் பண்ணிக்கோ. Write to latch, read from pin. Write to port latch, read from port pin. This you have to remember whenever you are writing a program. It is going to be program your IO pins. Fine. See, நீங்க வந்து உங்க டிவைஸ் ஏதோ ஒன்று கனெக்ட் பண்ணிருக்கீங்க அப்படின்னா, whether it is an input device or output device, you have to remember this concept. Write operation is always to the latch and read operation is always to the from the pin. Fine. Okay. Now initially நம்ம என்ன சொல்லிருக்கோம் அப்படின்னு பாத்தீங்கன்னா read latch. இந்த latch read பண்றதுக்கு பண்ணணும்னா இந்த buffer enable ஆகும். Correct? Yes or no? இந்த port registerல என்ன எழுதி இருக்குமோ அதை read பண்ணணும்னா எனக்கு என்ன ஆகணும்? This latch must get enabled. I hope everyone can understand what I am saying. Fine. If this pin has to be read, எது enable ஆகணும்? Read pin. This signal has to be enabled. Please understand what I am saying. இந்த buffer எப்ப enable ஆகணும்? Port registerல நான் எழுதின வேல்யூவை திரும்ப நான் read பண்ணணும். Fine. Yes. Okay. So இந்த buffer எப்ப enable ஆகணும்? Whenever I am doing input operation, read operation பண்ணா இந்த pin enable ஆகும். Write operation பண்ணா இந்த clock enable ஆகும். That's it. I hope it is clear. So we are having three things. What are they? Write to latch, read pin. The read latch one more option. The read latch எப்ப நமக்கு யூஸ் ஆகும் அப்படின்னு பாத்தீங்கன்னா read, modify, write. During that time only read latch is going to be useful. Fine. Kindly note down whatever I am saying. Initially இது மூணும் disable இருக்கு. Fine. What operation we are going to perform now? What operation we are going to perform now? என்ன ஆபரேஷன் இப்ப பண்ண போறோம்ப்பா? For what purpose we are having this slide? To understand the write operation. Yes, we are going to write 0. எழுதலாங்களா? Yes. Now listen carefully. இதை நீங்க ஸ்கிரீன்ஷாட் எடுத்தா புரிஞ்சுக்க முடியாது. என்டையர் வீடியோவும் பார்த்தா தான் புரியும். Fine. Please carefully listen. First, internal busல 0 எழுதுறோம். That means we are going to write the logic 0. Fine. உள்ள போய் ஸ்டோர் ஆகுமா latchல? இப்போ flip flopல போய் ஸ்டோர் ஆகுமா? Whether it will get stored into the latch or no? Yes or no? What is needed so that the logic 0 will get into the latch? Yes, very good, Danya. We have to give clock pulse. Fine. Now listen. Now write to latch signal is getting 1. So in the signal enable ஆகுது. கரெக்டா? enable ஆகுற டைம்ல என்ன ஆகும்? What about the logic of the latch now? இது enable ஆயிடுச்சு. What about the logic inside the latch now? Yes. Can you people type it in the chat? How it is 1? See, 1, it is a enable signal here. That's why it is mentioned as latch. Flip flop னு சொன்னா நம்ம என்ன படிச்சிருக்கோம்? Clock input னு படிச்சிருக்கோம். So here also we are having clock only. Fine. Fine. When this pin is getting 1, whatever the data we are having at D, it is getting into the latch. Correct? So what will get stored inside? கொஞ்சம் கேர்ஃபுல்லா லிசன் பண்ணி பதில் சொல்லணும். Yes, 0. Definitely latch குள்ள 0. Fine. Once it got written, clock again என்ன ஆயிடுச்சு? 0. Now internal bus content may be any value. Store ஆயிடுச்சு இல்லையா latchல? See, when you are executing the instruction, CLR P1.0 nu vechukkom. CLR P1.0. At the time, what is going to happen? Internal bus valiya the corresponding bit ku zero logic vanduchi. Correct? Correct? Exact latch enable ஆச்சு. உள்ள போய் இந்த zero store ஆயிடுச்சு. Fine. Now latch will get disabled. Now internal bus content can be anything. Whatever the content, now it won't get into the latch. Why? Now the latch get disabled. Whenever the pin goes from 0 to 1, the data available in the D input getting into the latch. Otherwise what? It gets into the memory state. Now it is in memory state. Meaning any value internal bus la vandalum ulla pogadu. Correct? Similarly, inga 0 dana store aayirukku. So இந்த buffer வழியா இந்த பக்கம் போக முடியுமா? Buffer disabled. So இந்த பாத்தும் நமக்கு என்னது? Open circuit மாதிரி ஆயிடும். Fine? Yes. அதே மாதிரி பின்னோட லாஜிக் இங்க ரீட் ஆனாலும் இந்த buffer enable ஆனதா அந்த லாஜிக் இங்க வரும். Fine? Now the value gets stored into the latch is logic 0. What about the output at Q? D flip flop oda operation நம்ம எல்லாருக்கும் தெரியும் நம்புறோம். Fine? What about the output at Q terminal? Q ல என்ன output வரும்? On seeing this diagram, you can see very good 0. What about the output at Q bar? Yes, very good 1. What about the input to the field effect transistor gate? Gate input என்ன லாஜிக்ல இருக்கு? 1 only. Fine. உங்களோட gate terminal நீங்க 1 logic பண்ணீங்க அப்படின்னா whether the transistor will get into on state or off state. Gate terminal now 1 பண்ணிட்டேன். Now the transistor is going to be on state or off state? On state, very good. கண்டிப்பா transistor on ஆகும். Transistor on ஆன meaning என்ன? இந்த path almost ஒரு short circuit. That means this pin is connected to ground now. Can you people imagine like this? இங்க நான் latchல 0 எழுதுனதுனால இந்த transistor on ஆச்சு. இந்த transistor on ஆனதுனால எனக்கு ஆல்மோஸ்ட் இந்த field effect transistor on na meaning என்ன? You consider this bit as a switch. So the path close side, that means this pin is connected to ground. What about the logic available at the pin now? What about the logic available at the pin now? 0. Very good. Very good. நம்ம latchல என்ன logic எழுதணும்? Port latchல என்ன logic எழுதணும்? 0. What is getting reflected in the pin? 0. I hope writing logic 0 எல்லாருக்கும் புரிஞ்சதுன்னு நான் assume பண்ணிக்கிறேன். Yes? Is this operation is clear to everyone? Okay. Now you people can take a screenshot. So latchல 0 எழுதிருக்கோம். So Q bar 1 கிடைக்குது. Transistor on ஆகுது. So this path is getting almost short circuit. That means this pin is at logic level 0. That's all. Okay. Can we go with writing logic 1 to port 1 pin? பார்க்கலாங்களா? Actually, எழுதுனது எங்க எழுதணும்? பின்ல எழுதணுமா? latchல எழுதணுமா? Where we have written the logic? Where we have written the logic? Port pinல எழுதணுமா? latchல எழுதணுமா? Yes, very good latch. That's why I told the word write to latch. நீங்க எழுதுற விஷயம் எப்பவுமே latchல தான் போய் ஸ்டோர் ஆகும். That's all. Fine. Now we will move with writing logic 1. இங்க என்ன நடக்கும் சொல்ல முடியுமா? இனிஷியலா என்ன பண்ணணும்? என்ன இன்ஸ்ட்ரக்ஷன் யூஸ் பண்ணணும்? set b யூஸ் பண்ணுவீங்க. கரெக்ட்டா? setb யூஸ் பண்ணுவீங்க. So what will happen? இந்த corresponding bit internal busல 1 வருது. Clock is getting enabled. latchல போய் 1 ஸ்டோர் ஆகுது. Now clock get disabled. So இனிமே internal busல எது வந்தாலும் எனக்கு கவலை கிடையாது. Now what logic is available in the latch? What is the logic available in the latch? 1. What about the output at Q bar? What about the output at Q bar? 0. Very good. 0. What about the input to the field effect transistor gate? 0. What about the condition of the field effect transistor? On or off? Very good. Off. Fine. We are going to consider if it is in off state, it is going to be a open circuit. The path on the open ஆயிடுச்சுன்னு வச்சுக்கோங்க. Now there is no connection between the ground and the port pin. Where this port pin is connected now? Kindly see the diagram and answer. It is connected to VCC through a pull-up circuit, correct? So this is connected in this way. So முன்னாடி ground ஓட connect ஆயிருந்த மாதிரி இருந்துச்சு. இப்போ எதோட connect ஆயிருக்கு? It is connected to VCC through a FET pull-up. Buffer பத்தி நம்ம பேசவே கூடாதுங்க. ஏன்னா ரைட் ஆபரேஷன் பஃபர் எனேபிள்ல தான், ஐ மீன் டிசேபிள்ல தான் இருக்கு. இந்த ரீட் பின் எனேபிள் ஆனா மட்டும்தான் இந்த பஃபர்ல இருந்து ரீட் ஆகும். இதே மாதிரி இது எனேபிள் ஆனதா latch ரீட் ஆகும். எஸ் கிளியர்? பஃபர் ரீட் பின்னை பத்தி நீங்க வந்து கவலையே பட தேவையில்லை. ஒய்? இங்க ஜீரோ லாஜிக் தானே இருக்கு. அப்ப இங்க என்ன வந்தாலும் உள்ள போகாது. அதே மாதிரி இங்க latchல என்ன இருந்தாலும் இந்த வழியா இன்டர்னல் பஸ்க்கு போகாது. Till the signal of the corresponding buffer will get enabled, the information is blocked. That's all. I hope it is clear up to this. What about the logic available in port pin now? இப்போ port pinல என்ன லாஜிக் இருக்கு? இது ஓபன் சர்க்யூட். இந்த பின் டைரக்டா VCC ஓட கனெக்ட் ஆயிருக்கு. That's all. One logic. So this we call it as sourcing. இது பேர் என்ன சொல்லுவோம் அப்படின்னு பாத்தீங்கன்னா sourcing அப்படின்னு சொல்லுவோம். ஸோ இங்க நம்ம 5 வோல்ட் இங்க கொடுக்குறோம்னா உங்க டிவைஸோட அனதர் டெர்மினல் கிரவுண்ட்ல கனெக்ட் ஆயிருக்கும். இங்க பவர் நம்ம கொடுக்கறதுனால இது பேரு சோர்சிங் அப்படின்னு சொல்லுவோம். சிமிலர்லி இதுக்கு முன்னாடி நம்ம பார்த்தது வந்து சிங்கிங். நம்ம லேப்ல பண்ணது எல்லாமே சிங்கிங். சிங்கிங்னா மீனிங் என்ன? கிரவுண்ட் நம்ம கொடுக்குறோம், பவர் வந்து வெளியில கொடுத்துருக்கோம் எக்ஸ்டர்னலா. தட்ஸ் ஆல். டோன்ட் கெட் கன்ஃபியூஸ். ரைட்டிங் லாஜிக் 0, ரைட்டிங் லாஜிக் 1. கிளியரா புரிஞ்சுதா எல்லாருக்குமே? எஸ் ஆர் நோ? Is it clear to everyone? Is this thing is easily understandable by you people? Have you people understood? See, we have spent more time for preparing this slide, especially. I hope it is clear to everyone. புரியலனா கேட்கலாம். Fine. Now, fine. Write operation முடிஞ்சாச்சு. அடுத்து நம்ம பார்க்க போறது என்ன அப்படின்னு பார்த்தோம்னா read operation. Fine. Okay. My first question: what you have to do to configure a port as input? இந்த port பின்ன இன்புட்டா கான்ஃபிகர் பண்ணனும்னா ஃபர்ஸ்ட் நீங்க பண்ண வேண்டிய விஷயம் என்ன? Finally type it in the chat. So அதே port 1 ஓட அதே சர்க்யூட் தான் இப்போ நம்ம பார்க்க போறது input operation, read operation. Yes, we have to set the corresponding bit. So அப்ப அந்த latchல நான் என்ன வேல்யூ ஃபர்ஸ்ட் ஸ்டோர் பண்ணனும்? To configure it as an input port, what value I have to store it in the latch? I have to write logic 1 to the latch. Fine? Okay. That is the first step. To configure a port pin as input, logic 1 must be written on its corresponding port latch. Fine? So now we are writing 1. Fine? 1 எழுதியாச்சு. What about the output at Q bar? Q bar ல என்ன இருக்கும் logic? 0. So what about the condition of the transistor? Off state. Very good. So this path is going to be open circuit and it is connected to 1. So இது நம்ம already write logic 1 க்கு நம்ம என்ன பார்த்தோமோ same operation. The same method you have to use to configure a port pin as input. Right operation தான், வேற ஒன்றும் கிடையாது. நம்ம first பண்ணது என்னது? Right operation. By that means we are configuring the port as input. Okay. Now you imagine, now you people imagine, I am going to connect an input device. And the input device என்ன logic கொடுக்குது? What about the logic given by the input device now? 1 only. Fine. So already பின்னோட logic 1 தான் இருக்கு. நல்லா கேர்ஃபுல்லா அப்சர்வ் பண்ணணும். நான் டிவைஸ் எதுவுமே கனெக்ட் பண்ணலனாலும், இன்புட் டிவைஸ் கனெக்ட் பண்ணலனாலும் எனக்கு பின்ல என்ன லாஜிக் இருக்கு? 1 தான் இருக்கு. கரெக்டா? நான் இன்புட் டிவைஸ் கனெக்ட் பண்ணி அது லாஜிக் 1 கொடுத்தாலும் பின்ல என்ன லாஜிக் இருக்க போகுது? It is going to be 1 only. Fine. This kind of thing we call it as quasi bidirectional port அப்படின்னு சொல்லுவாங்க. பேரு quasi bidirectional port. device எதுவும் connect பண்ணல அப்படின்னாலும் it is going to maintain a logic 1. Even if I connect a device with logic 1, at that point of time is also logic 1. Fine. So இன்னும் சிம்பிளா சொல்லணும்னா இது bidirectional port ஓட functionality இருக்குது, but it is not the exact bidirectional. Fine. It is not a exact bidirectional. Fine. That's why it is called as quasi bidirectional. Fine. இப்போ மீனிங் என்ன? Input device connect பண்ணாலும் logic 1 தான் கிடைக்கும் read பண்ணா. Input device with logic 1 connect பண்ணாலும் 1 தான் கிடைக்கும். Fine. So it is not a true input port. It is not going to be a true input port. Fine. Output operation பக்காவா நமக்கு நடக்குது. Fine. Input operation அப்படின்னு சொல்றப்ப கண்டிப்பா 8051ல உள்ள port 1 என்னது? It's not a true bidirectional pin. Fine. That's why it is called as quasi bidirectional port அப்படின்னு சொல்றோம். Fine. Now இப்போ logic 1 இங்க இருக்கு. இப்போ நான் ஒரு இன்ஸ்ட்ரக்ஷன் எக்ஸிக்யூட் பண்ண போறேன். என்ன அப்படின்னு பாத்தீங்கன்னா move c, p1.0 ன்னு வச்சுக்கலாம். move c, p1.0. What about this particular operation? Read operation or write operation? Port பின்னன்ல நான் ரீட் பண்றேனா இல்ல ரைட் பண்றேனா? You have to check whether the bit is source or destination. It is source. That means it is a read operation. Fine. இப்போ நான் read operation perform பண்ண போறேன் அப்படின்னா எந்த சிக்னல் enable ஆகும்? Out of the 3 signal, read latch, write to latch, read pin. Which signal is going to be enabled now? எந்த signal enable ஆகும்? Out of the 3 signal, yes, read pin signal will go 1. The signal enable ஆனிச்சுன்னா என்ன நடக்கும்? What will happen? The input to this buffer is directly connected to the pin. Pinல என்ன லாஜிக் இருக்கோ அதான் input. Correct? Fine. So that is going to be available at the internal bus. Correct? So what about the logic available in the internal bus now at this moment? இந்த மொமெண்ட்ல இன்டர்னல் பஸ்ல என்ன லாஜிக் ரீட் ஆகி போகும்? 1. ஓகே, நல்லா இமேஜின் பண்ணி பாருங்க. இப்போ லாட்ச் டிசேபிள்ல இருக்கு, அப்ப இங்க வர லாஜிக் உள்ள போக முடியாது டெஃபினட்டா. ரைட், தட்ஸ் ஃபர்ஸ்ட் பாயிண்ட். தென் இங்க உள்ள லாஜிக்கும் எனக்கு உள்ள வர முடியாது. திஸ் லாட்ச் இஸ் ஆல்சோ டிசேபிள். இந்த லாட்ச் என்ன இருக்கு? ரீட் லாட்சும் டிசேபிள் ஆயிருக்கு, ரைட் டு லாட்சும் டிசேபிள் ஆயிருக்கு. எது எனேபிள் ஆயிருக்கு? ரீட் பின் எனேபிள். தட்ஸ் வை ஐ அம் ரிப்பீட்டட்லி சேயிங் write operation is always to the latch. It will get reflected in the pin. But read operation is from the port pin, not from the port register. Kindly understand this concept. So, இது புரிஞ்சதுனாலே உங்களுக்கு clarity கிடைச்சாச்சுன்னா that's all. Fine. Now, suppose if my input device goes logic 0, what happens? இப்போ இந்த மொமெண்ட்ல input device 0 logic போனா என்ன நடக்கும்? No change. How? If input device 0 logic கொடுக்குதுன்னா irrespective of the pull-up value, it is directly connected to logic 0. See, இந்த பின்னை எப்போ வந்து 0 logic கொடுக்கணுமா? What is the equivalent for 0 logic? Ground. So this pin is directly connected to ground. So அப்ப இங்க என்ன லாஜிக் இருக்கும்? 0 தான் இருக்கும். Even though we have a pull-up circuit, can be pulled low by the input device. Who is dominating now? The input device. So it is deciding which logic has to be given at the pin. Fine. So what about the content getting inside now? 0. So difference purida? Device 1 logic கொடுத்தா உள்ள 1 போகுது, 0 logic கொடுத்தா 0. That's all. So that's all about the read operation. Is it clear to everyone? Is it clear to everyone? Yes? Okay, fine. Now, write operation பார்த்தாச்சு, writing value 0, 1 பார்த்தாச்சு, reading value 1 and 0 பார்த்தாச்சு. Fine. Now we are going to discuss about the read, modify, write operation. கொஞ்சம் நல்லா கேர்ஃபுல்லா கவனிங்க. First, initially we are going to assume latch la 1 irukku eduthu. I am assuming the latch is previously having the value 1. I am assuming. Okay, fine. Now, what about the output at Q bar? Q bar la enna logic? 0. Fine. What about the condition of the transistor? What about the condition of the transistor? Off state. Fine. So it is going to be an open circuit. So it is pulled high due to the pull-up circuit. So we are having the logic 1. So latch la 1 irundha, pin li 1 irukku. Fine. Now read, modify, write operation. Ida perform pandradhukku enna instructions sonnom? Best example, CPL P1.0 we can consider. CPL P1.0 we can consider. இப்போ நம்ம read, modify, write operation பார்க்க போறோம். Fine. So first என்ன நடக்கும்? CPL instruction execute ஆனா first என்ன நடக்கும்? It is not a read operation, it is read, modify, write operation. What about the first thing? Port latch read ஆகும். Correct? Yes. So out of the 3 signals, which signal must get enabled now? Read latch, write to latch, read pin. The 3 signal la edu enable ஆகும். In the instruction execute. Yes, very good. Read latch. So that signal goes 1. So the 1 logic ponuchana, what about the input to this buffer? 1. So what about the output from the buffer? It is going to be 1 only. So internal bus ku latch oda status poyachi. Fine. This internal போய் ஏதோ ஒரு மெமரில ஸ்டோர் ஆகுது. 1 ஸ்டோர் ஆயிடுச்சு. இப்போ read latch disable பண்ணியாச்சு. What happened? That's all. இதான் இப்போதைக்கு உள்ள சினாரியோ. Fine. Once அது read ஆகுற வரைக்கும் என்ன ஆகுது? Read latch enable இருக்கு. Once அது read ஆகி முடிஞ்சதுக்கு அப்புறம் read latch signal gets disabled. Fine. இப்போ 3 சிக்னல்ல disable தான் இருக்கு. The content is red. Read ஆயிடுச்சு. Fine. CPL, what is the meaning for that? What is the meaning for that? Complement. If the data complement ஆக போகுது internal CPU ல. So இப்போ 1 becomes என்னவா மாறும்? 0. Now this modified data, it is going to be right back into the port latch. இப்போ என்ன signal enable ஆகும்? So internal bus la இப்போ 0 வச்சாச்சு. இப்போ எந்த signal enable ஆகும்? Which signal will get enabled now? Out of the 3 signal, read latch, write to latch, read. எந்த signal enable ஆகும்? No, Anthony Surya. Read பண்ணியாச்சு, modify பண்ணியாச்சு. Again it has to be write back. So write to latch signal is going to be enabled. So internal bus la இப்போ 0 இருக்கு. So 0 store ஆயிடுச்சு. So Q become 0, Q bar become 1, transistor is going to on, so it is going to connected to ground, so output becomes 0. Fine. முன்னாடி 1 எழுதிருந்தோம். Output pin, I mean pin லயோ logic 1 தான் இருந்துச்சு. CPL instruction execute ஆனா first என்ன ஆகுது? Read latch enable ஆகுது, latch read ஆகுது, then modify operation takes place. Again write to latch signal enable ஆகுது, it is placed again into the latch. So that the condition of the port pin 1 ல இருந்து என்ன மாறிடுச்சு? 0. So this we call it as toggle operation. The other word we can say it as toggle operation. இப்போ 0 இருக்கு. இப்போ திரும்ப CPL instruction execute ஆனா என்ன ஆகும்? Can you people imagine? 0 will get read, it will be complemented as 1, then again 1 will be written on the latch. So pin la 1 logic 1. So to change the logic, invert the logic of the port pin, we can use CPL instruction that is going to be a read, modify, write operation instruction. That's all. Set B clear, rendume write operation. Move C comma bit, that is read operation. Move bit comma C, that is going to be a write operation one. Fine. Whereas complement, it is going to be read, modify, write operation. I hope you people understand write operation, read, modify, write operation. Yes. Port 1 clear up. Fine. Exam point of view, for example, descriptive type question கேட்கணும் அப்படின்னா explain the output operation of port 1 அப்படின்னு கேட்கும். ஸோ அந்த டயக்ராம் வரைஞ்சி நம்ம என்ன எக்ஸ்பிளைன் பண்ணணும், லாஜிக் 1 எழுதுனா பின்ல என்ன லாஜிக் வரும், லாஜிக் 0 எழுதுனா பின்ல லாஜிக் என்ன வரும், தட் போர்ஷன் யூ ஹேவ் டு எக்ஸ்பிளைன். ஆர்எல்ஸ் கொஸ்டின்ல எப்படி கேட்கலாம், எக்ஸ்பிளைன் தி ரீட் ஆபரேஷன் ஆஃப் போர்ட் 1 அப்படின்னு கேட்டோம்னா யூ ஹேவ் டு கோ வித் தட். ஸோ ரீட் ஆபரேஷன் எக்ஸ்பிளைன் பண்ற மாதிரி. ஃபைன். ஆர்எல்ஸ் யூ கேன் பி ஆஸ்க்டு explain the read, modify, write operation. So அப்போ கேட்டோம்னா this portion you have to explain. That's all. See, animation for your understanding purpose we have created. Okay, fine. I hope it is understand by everyone. So that's why we are spending more time for preparing this line. Fine. So that's all about port 1 operation. Okay, now we will go with other port. Fine. Probably we can complete port 0 today. Port 1 mudichachi, port 0 we may complete by today itself. Fine. Shall we get into port 0? Shall we get into port 0? Yes? Okay. Fine. Alternate function irukku appdin sonnale definitely anga enna vandirukkum. What we must be have. It is doing dual purpose, but only one can be done at a time. Which concept can be used there? ரெண்டு விஷயத்துக்காக அந்த பின்னை யூஸ் பண்ணலாம். எஸ், எனேபிள் சிக்னல், ப்ராபபிலி எனேபிள் சிக்னல். ஓகே, இன்னும் கிறிஸ்பா நான் சொல்லணும்னா 2 இன்புட் ஃபங்க்ஷன், அதுல எது நமக்கு அவுட்புட்ல இருக்கணும் அப்படின்றத செலக்ட் பண்ணணும். Out of 2, yes, very good Danya. We have to go for the concept called multiplexing. Fine. Now operation of port 0. So this is the circuit of port 0. Fine. Here also you have a port latch and 2 buffers. Okay, one to enable the pin reading. The another it is for reading the latch. Okay. Then one more signal we are having, write to latch. Fine. Then we have 2 field effect transistor. On the மேல இருக்கு, இன்னொன்னு வந்து கீழ இருக்கு. Fine. Then we have a multiplexer. So the multiplexer பொறுத்த வரைக்கும் if the control line is 0, it is connected to the lower portion. If the control line is 1, it is connected to the upper portion. That's why it is marked as 0 and 1. Fine. So we are having a multiplexer, a NOT gate, AND gate. That's all. Fine. So we start with the working. Shall we start with the working? Yes, fine. Okay. Generally, when I am doing IO operation, the control line must be 0. Control line enna logic irukano? 0. Why? Port operation, input output operation பண்றப்ப, see port 0 க்கு alternate function இருக்குன்னு சொல்லிருக்கோம் இல்லையா? So அதுக்காக தான் இந்த multiplexer இருக்கு. Similarly, what I have told for port 1, this is only 1 bit of port 0. Similarly, the other 7 bits will be same like this. இதே மாதிரி 7 சர்க்யூட் இருக்கு இன்னும் port 0. Fine. Okay, my question is, for port operation, what about the status of the control signal? Control signal enna logic la 0 or 1? You can see the diagram and tell the answer. Mux வந்து இந்த port latch ஓட connect ஆகணும்னா இங்க என்ன லாஜிக் நான் எழுதணும்? control 0. Very good. If I write 0 at the control pin, we no need to consider the address or data. If address or data or no need to bother about it. Why? Because the multiplexer input is connected to, the output, complemented output of the port latch is connected to the transistor if the control signal is 0. Correct? So in the pin Q bar, it is connected to the field effect transistor. Fine. Now the address or data content we are not going to bother. Fine. So now we are getting 0, output of the AND gate 0 ஆயிடுச்சு அப்படின்னா, what about the upper FET? மேல உள்ள டிரான்சிஸ்டர் என்ன ஆகும்? ஆன் ஸ்டேட் ஆர் ஆஃப் ஸ்டேட்? control input 0 ன்னு சொல்லிட்டாலே இந்த AND கேட்டோட அவுட்புட் 0 தான், irrespective of the other input. So automatically the upper FET will go into off state. That means it become open circuit. Fine. Fine. Now we are going to consider, we are going to write the logic 1. Sorry, 0. Writing logic 0 that from basic. So 0 internal bus la vandachi. Which signal must get enabled now? Out of the 3 signal, read latch, write to latch, and read pin, which signal must get enabled now for write operation? In the signal, yes, write to latch enable aichi, 0 ulla poi store aichi. Now write to latch get disabled. So internal bus la enna content irundhalum kavala kedaiyadhu. What about the output at Q bar now? What about the output at Q bar now? Latch la 0 irukku. So adala output Q bar enna varum? 1. So the 1 enga podu field effect transistor ku poidum. As the control signal is 0, this port latch, complemented output of the port latch is connected to the field effect transistor. So what about the lower FET condition? On or off state? On state la irukuma, off state la irukuma? On state. So what about the logic of port pin? So this field effect transistor on state nu sonnamna, it is directly connected to ground. Fine. As an ideal representation. Okay. Generally, there may be some voltage drop across this field effect transistor, but ideally we are considering this pin is connected to ground. So port pin la logic 0. That's it. Fine. Similarly, writing logic 1 pakalama. Shall we go into writing logic 1? Yes. Okay. Fine. So the same thing. India leda control 0 nu sonnamnale address data don't care. So mux enga connect aayirukka podu namakku complemented output of the port latch. It is getting as a input to field effect transistor now. Fine. So mela ulla FET ipo off condition la da irukum as we are doing IO operation. So now internal bus la 1 elidhiyachi, latch la poi 1 store aidichi, latch disable aidichi. Then no need to bother about the internal bus content. Now what about the status of Q bar? Zero. Very good. What about the condition of the lower FET? Off. That means ரெண்டு டிரான்சிஸ்டரும் ஆஃப் ஸ்டேட்ல இருந்துச்சுன்னா இந்த பின் ஆல்மோஸ்ட் எப்படி இருக்குன்னு சொல்ல முடியுமா? It is open. இதுவும் ஓபன், இதுவும் ஓபன். What about the condition of the pin now? This scenario we call it as floating. This scenario we call it as floating. இது பேர் என்ன சொல்லுவோம் அப்படின்னு பாத்தீங்கன்னா high impedance state அப்படின்னு சொல்லுவோம். Neither connected to logic 1 nor connected to ground. VCC லயும் connect ஆகல, ground லயும் connect ஆகல. Correct? So this scenario we call it as what? இது பேர் தான் என்ன சொல்லுவோம்? High impedance state or the pin is floating. If I am saying a port as an input port, this must be like this. ஒரு port input ஆ இருக்கணும்னா இதுதான் condition. இந்த port pin என்னவா இருக்கணும்? Neither 0 nor 1. It is based upon the input. Okay. But as of now, we are discussing about the right operation. Fine. Now, this port pin is floating. That means high impedance state la irukkudu. Fine. எனக்கு என்ன லாஜிக் அவுட்புட்ல வேணும்? நான் latchல என்ன எழுதிருக்கேன்? 1. பின்ல என்ன லாஜிக் வேணும்? 1 லாஜிக் வேணும். Fine. Unfortunately, the pin is floating. What we have to do for port 0? Port 1 நம்ம படிக்கிறப்ப இன்டர்னலா புல் அப் சர்க்யூட்ல இருக்குன்னு பார்த்தோம். கரெக்ட்டா? Port 0 ல அந்த மாதிரி புல் அப் சர்க்யூட் கிடையாது. So what we have to do? What we have to do? உள்ள அந்த சர்க்யூட் இல்ல. Yes, very good. Externally we have to create a pull up circuit. Yes, shall we create? So what we have to do for that? ஒரு ரெசிஸ்டரை அந்த பின்ல இருந்து 5 வோல்ட்ல கனெக்ட் பண்ணணும். Port 0 requires external pull up circuit. Yes, the circuit நம்ம கனெக்ட் பண்ண உடனே என்ன ஆயிடும்? It will be like this. So இப்போ pin எது கூட கனெக்ட் ஆயிருக்கு 5 volt ஓட கனெக்ட் ஆயிருக்கு through a resistor. What about the logic available at the pin now? இப்ப bas very good one logic. Yes, one logic நம்ம லாஸ்ட்ல எழுதணும், pinல one logic வந்தாச்சு. That's all. See, with this we will stop today's session. The remaining portion we will continue in the next session. Okay, so இன்னும் நம்ம வந்து இதுல என்னென்ன பார்க்கணும், read operation of port 0 பார்க்கணும், then alternate function of port 0 பார்க்கணும். Fine, so that we will continue in the next session. Fine, so by this topic we will wind up today's session.